I forgot the exact number of the circular. They have advised us to use it as cold standby rather than hot standby. So make sure you are using your DME cold standby. So this is the main station setup. Now this is common setup basically. This is common for both transmitter. If you want to go for the individual transmitter, so you have to go inside the transponder setup. So for transponder setup, this is the power 100. This is percent power. So what we can do using this, it is not advisable, or I have also seen this some. If I want my one transmitter to be at higher power and other transmitter to be at lower power, or say our FIU aircraft is reporting different, he is saying for transmitter 1 power is sufficient, but for transmitter 2 please increase power little more. So we can do this, or reduce power, we can do this from here. Because if say FIU aircraft say कि यार आपका एक ट्रांसमीटर का तो पावर ठीक है, दूसरे का इशू है. So from station setup, if I do this, make this, if I say उसने बोला थोड़ा increase करो, तो मैं यहाँ से 110 कर देता हूँ. So I will be increasing the power for both the transponders. But from here I can control the individual power. So this is rarely happens, but this is very frequent in DVR. So this is similar sort of PMDD, similar structure is there in DVR also. But here in DME it is very not a problem generally, but with DVR it is their problem. So in DVR we generally keep this station setup to be maximum, which is like 100 watt, and we reduce power from here. So as the headquarter has instructed to keep it 70 watts, so in case of DVR we generally reduce this power from here. So I will keep both of these as 70%. So in case FIU aircraft from here individually, this is its main function. So other thing setup options is like pulse rate, you leave it as per station setup. Ident also I can put different ident in different station, but whenever there is as per station setup means it will be following instruction of this station setup. Whatever is filled in this station setup, this one will go there as per station setup. These are non-configurable. Then one more thing is executive monitor setup is just nothing important in this. One more, these are the limits. One important thing was in communication setup. I will discuss. Yeah, maintenance. In maintenance, okay, after setup, there is that tab is maintenance. This maintenance tab, okay, I will give a pause here and you can ask question if any till here, or then I will continue with the this maintenance. Little drink break. If any question you can ask.
Sir, Vikram Singh connects from Bhavnagar Airport. I have one question.
Yes, Vikram Singh, go ahead.
Sir, if one monitor was showing a write system delay and in one monitor there is some error was there in monitor delay, then we have to calibrate both the monitors, or single monitor we can calibrate, sir?
In single monitor can be calibrated also.
Okay, okay.
But advised only to calibrate it after the flight calibration.
Okay. Okay.
Or here from this, these steps are there. Na? In this step, there is one step here. This is the, can you see this? This output.
Yes.
Here, this time delay. This time delay monitor reading calibration. Step 6. Can you see this?
Yes, sir.
So this is for individual monitor 1, monitor 2. You can run this for
We are
individual
having
monitor.
old version. We are having old version DME. That's why I can.
Okay. Old same. This is not different. In old version also, it's not different. I mean, only interface is different, but more or less it is same. Calibration, monitor calibration done in older version also.
Oh, okay.
I don't have the screenshot, but you can do.
Oh, okay, sir. Okay.
So this is maintenance portion. In maintenance, the main here is calibration. So it is advised to follow this step. So these basically what the equipment manufacturer has done, instead of putting transmitter calibration, monitor calibration separately, what he has done, he has made a series of steps. So in these series of steps, first 4 or 5 steps are of transmitter adjustment, and the last 5 to 10 steps are of monitor adjustment, different things. So the screenshot of the same as I have kept here. So generally, these are advised when we install the equipment at first. So when we switch on the equipment, it is equipment manufacturers advised to follow all these steps properly first time, and for both the transmitter. Then later it is not need not to be required until unless some cards has been replaced, like LP, HP, or any card has been replaced. Then only it is required to recalibrate it. Otherwise, only first time we did, so that is sufficient. So for that, these are the different steps. Total 10 steps of there are there. As I just told you, this first 4 steps are basically related to transponder, and the later 5, 6, 7, 8, 9, 10. These steps are related to more or less your receiver or monitors. So this is first step, as you can see, the transmitter drive level optimization. What it do is basically optimize your pulse. So they are within a limit, and this is done in this step. The next step I already discussed is transmitter power calibration. So in this step, I am actually changing the radiated power, either increasing or decreasing. So third is auto time delay. This is also for this your monitor checks the pulses which are generated for 50 microsecond to check the 50 microsecond delay is there. So next step is this processing delay. This is the main step, fourth step, which is required at the time of calibration as well. So in this step, what I am doing is I am changing the system delay of my DME. I am either increasing or decreasing the system delay. So this step number 2 and step number 4 are important. This is for transmitter power, and this is for transmitter system delay, transponder system delay. So these steps are carried out only for the transmitter on air. So here my current active path is transmitter 1. So now if I start calibration, this calibration will be performed on transmitter 1. So similarly, if I do the changeover and now this is transmitter 2, if I perform again, I have to perform all the steps, and this calibration will be done for transmitter 2. So now this next fifth step is monitor interrogations. This is are related to our monitors. Here, this is monitor interrogation level calibration. We have to run both these. It will show green tick like this here. So next is time delay monitor reading calibration, which you just asked, that this is to read it as 50 microsecond. This is effective radiated power monitor reading calibration also. You run this ERP. This is VSWR. This monitor here in executive monitor setup. Sorry, this monitor. Yeah, this one here is. Yeah, this reading one. This is also in DME is given as this is given as a executive parameter, antenna VSWR. So I have checked, initially I have checked this, my VSWR is for antenna yesterday, which I discussed, is 1.05 or something. So I'm sure that now antenna is 1.05. I can calibrate this from here. So it is basically, the process is just run this, it will automatically calibrate this VSWR. So whenever it will increase, it will show. So it is advisable to run this VSWR monitor reading only on load. So because for open, you have to open the RF cable. So just run it on load only. Don't run it on open. So only load part you have to perform. Next is this power output monitoring calibration. This is again monitor reading only. Your monitor is not reading your power correctly, so you can read it as per your requirement for both the monitors. And this last one is your receiver sensitivity one. So this step takes time. It will change your system will say, your monitoring part will be out for like, I think 5 to 10 seconds or so. So this is the final step. So these are the calibration step, all the 10 step in the calibration. And out of these 10 calibration step, we will use 2 only in flight calibration generally. So here you can see this, this is giving me the error, warning it is giving me. Can anybody tell me why this warning is coming?
Not calibrated, sir.
Not calibrated. I think no, ये reason नहीं है. I think we have to make sure, we have to check. This can happen at station also. So this monitor executive limit setup, this one. If I am putting this over here, so this, as you can see, the nominal power here is 100 watt only. Even if I put my station, let me check. Yes, here station setup is 100 watt power. So I have reduced the power from here 70%. So there is this catch. So monitor limit setup are dependent on this setting. So if I put this 70 here, now I can see this. So, okay, now I have two station setup. I have it's not reading properly. So now, as you can see, now I have kept it as 70 watt here. So my monitoring limits has been amended accordingly. The executive monitoring limits that has been amended accordingly. So these limits now has been, the reference is now this. So warning and this is changed as per. So this is one drawback of using, if I do this, यहाँ पर मैं अगर 100 छोड़ता हूँ और मैं यहाँ से इसे reduce करता हूँ, तो ये इसका भी एक drawback है. So it is advisable only to change the station setup here. But the problem in this type of is this, you cannot increase the power of single transponder. You have to increase both the power of both these. So if FIU is reporting there is a problem, there is a range issue with one transponder. So you cannot, you have to increase the power for both. This is the problem with this. So other, besides this calibration, these are the normal certification. In advanced control one, there is important thing is ident key. Sometimes you have to switch off the ident. So this is the place where you can switch off the ident or on or make it continuous. So this is also important. Other rest is like user management. This everybody knows this user management, add user, delete user, time, version thing. This is all long. So this is the main overview of your DME. Now I will come to this Last measurement we have done, flight calibration. Flight calibration is very relatively simple and very extremely simple for DME. So actually there are parameters in DME which you can't control. So if aircraft is not receiving properly, so there is nothing much you can do. So generally there are only two adjustments being asked by FIU. So first is system delay adjustment. I will repeat how it is done. And another is power. So it can report, okay, I'm not getting sufficient range of DME. So your coverage is less, especially in hilly areas or somewhere else. And other, it will ask you to put your equipment on standby to check the power. Sometimes where it will basically what it do is you put your equipment on standby power supply. By standby power supply, I mean batteries. Then it will go for coverage and it check whether your coverage is within ICAO limits, even if your transponder is on standby supply. So for system delay adjustment, again, it is simple. You go to this fourth step directly. Whichever transponder is on air, FIU is asking, please increase system delay by 0.1 microsecond. So this is 50 microsecond current set point. It is asking you to increase it by 0.1 microsecond. You simply put 49.9 here. So the system delay will increase by 0.1 microsecond. The same will be reflected in your monitor also. Do cross check with monitors. So before every flight calibration is there, you normalize your monitor, then so that the direct correlation can be seen. So you put 49.9 here and your monitor will show the reading and the same will be in the air also. Again, if FIU asks you to reduce your system delay by a 0.2 microsecond, so you simply put 50.2 here. So your system delay will be reduced to 0.2 microseconds. For power, I told you earlier also, for power, if coverage is not there, everybody knows how to put equipment on standby supply. This is need not to be told. Just simply switch off this AC supply here. So your equipment will be on the DC power supply. So when you do the coverage, it will ask you to increase the power. If it is not getting sufficient coverage, you just simply, if you can change the station setup configuration and increase this power to 80, 90, whatever it is asking. So this much is only in the flight calibration. So if there is some problem in this, generally this is 9 out of 10 times this will work okay. But if there is any problem, so I don't think we can do much there. We just go through the entire path again, all the measurements, which I told here, all the measurement, these voltages, these frequencies, if all it is okay, then your DME will work just fine. So this is all about DME, and I think I have summarized all and every aspect. If you have any question, then you can ask. Okay, one more thing is there in communication setup. I was discussing communication setup. Yeah. So yeah, there's a little confusion sometimes. See, here is local PMDT on IP network. So this is little confusing sometimes because here it has declared the IP starting from .1 to 100. Only on these IPs this PMDT will work basically. So at some station people have kept different IP and their PMDT is not running, so they just wondered कि क्यों नहीं चल रहा है. So you have to just check it. So it's relatively simple. It's not that tough, and rest is okay. This is defined already. SU and all these defined. So this is all there is. Thank you very much. और आपको कुछ पूछना है जिसको they can ask. ठीक है पंकज सर. और DME में इतना ही था मैक्सिमम जितना I have told them. बाकी क्वेश्चन they can ask. Any problem किसी स्टेशन पे आ रही है कोई चीज है they can ask.
Participants, if you are having this equipment at the station and if you are facing any issues then you can please raise the questions to Piyush. He is there to help you out. Please.
ट्राई कर लेंगे सर.
Fine, Piyush. Actually, this is a new setup here at Shady. We are having Intel and DME.
Okay.
Different stations are having
हाँ
different
सर, ये तो
DMEs
है.
over here.
Intel can DME is relatively good. वैसे अच्छा, ये भी सही है. Intel can be अच्छा था.
Yes, it's almost similar only.
ये-
Those settings are uh, a bit different. Here the calibration tab is there, as you have shown. Some stepwise mechanism is there. In this,
आपके Intel
it's
can
not like
DME
that.
में वो which I told power sensor sort of चीज दी थी उन्होंने, छोटा सा लेडीबग करके कंपनी का. अगर आपने वो
Yes, yes, yes.
उसकी
Yes, we
एप्लीकेशन.
have that bird power sensor for measurement of output power.
Okay.
So thank you, Piyush,
Okay,
very
sir.
much for RCDU team for imparting their knowledge to all the participants. It was really a very fruitful session. I
ठीक
hope
है. ज्यादा
everybody have.
सर ज्यादा बोरिंग तो नहीं हो गया ना इसमें? ठीक है. कोई मतलब
No.
कोई
This
नेगेटिव.
actually, this is equipment based, na.
हम्म.
Whatever you have shown, you have this in your laptop.
हाँ सर, इन लैपटॉप में.
Okay, this configuration setting that is available with you. Okay, very nice here. It's really nice to see that we can do so many things, yeah, from there. Uh, very appreciable training, Piyush. Thank you.
ओके सर, थैंक यू वेरी मच. थैंक यू वेरी मच ऑल जो भी प्रेजेंट रहे.
Thank you, dear participants.
और किसी को अभी भी कोई क्वेश्चन हो, दे कैन
Next,
कांटेक्ट मी ऑन मोबाइल
in
आल्सो.
coming days, as sir was telling, we will begin with some other training. Then again, you all be requested to please join and share your information and learn as much as possible. Thank you. Thank you very much.
श्योर. थैंक यू वेरी मच सर.
Thank you. Thank you, Piyush.
Hello, Piyush sir, are you there?
या
Sir, Vikram from Bhavnagar.
हाँ
सर
विक्रम
इन
बोलो.
आवर हमारे एक मॉनिटर में ना सर अलार्म आ रहा है सिस्टम डिले का, ठीक है सर. और एक मॉनिटर में ओके मतलब विद लिमिट है.
ठीक
तो
है.
हमें तो फ्लाइट कैलिब्रेशन का वेट करना पड़ेगा या अभी कैलिब्रेट कर सकते हैं, ये डाउट है.
ठीक है.
मोबाइल पे बात करो, बताता हूँ. ठीक
मोबाइल
है.
नंबर सर.
मैं इधर कमेंट में लिख देता हूँ.
ठीक.
I put my mobile number in comment. You can call.
ओके.
ठीक. ओके.